Good morning, everyone. So here I am Priyanshi Shukla going to telling about the kinematics and the kinetics in two dimensions. Before discussing about it, we have to know about some basic fundamentals. Here, a graph between the x-axis and the y-axis is given. So we are studying about the two dimension. So a graph between the x-axis and the y-axis is made, and a curve between the x-axis and the y-axis is given. If we draw a radius vector passing through the point P and touches the arc, then it is known as the radius vector, and this OP length is known as the R, which is also known as the radial length. And if we draw a tangent line passes a point P and making an angle of psi degree and making an angle of psi, so it is a tangent line. And if we draw a perpendicular from a origin to a tangent line, it is known as the perpendicular distance. Here this is x distance and this is the y distance, and the half of the arc is known as the arc length, and so it is represented by s. Here r, it is the length of the radius vector of position point of position OP. This theta, it is an angle which radius vector makes with the initial line. So here theta is the angle which radius vector makes with the initial line. Psi, it is an angle which a tangent at P makes with the x-axis. So this is the psi angle which a tangent line makes with the x-axis. Phi, it is an angle between the radius vector and the tangent at point P. This is the phi which a radius vector and the phi makes. S, it is the length of the arc of the portion AP and is known as the arc length. This length. P, it is the length of perpendicular from the origin on tangent. This one. So psi is equals to theta plus phi. Now, where we have a following types of curve. Intrinsic curve, a curve which is represented in the terms of s and psi is known as the intrinsic curve. Here, s is equals to f psi. Cartesian curve, a curve which is represented in terms of x and y, that is y is equals to fx, is known as the Cartesian curve. Polar curve, a curve represented in terms of the r and theta, that is r is equals to f theta, is known as the polar curve. Pedal curve, a curve which is represented in terms of p and r, that is p is equals to fr, is known as a pedal curve. Parametric curve, a curve which is represented in terms of any parameter, is known as its parametric curve, that is x is equals to xt and y is equals to yt. We have to note down these important points. We must have to remember these all points and these also. Okay, now what is a curvature? The bending of a curve at any point is known as the curvature at that point. If we have to know about the radius of curvature, then what is the radius of curvature? The reciprocal of a curvature is known as the radius of curvature. It is denoted by rho. The radius of curvature for curve s is equals to f psi is given as rho is equals to ds upon d psi.